Okay, next up is question 2, and in part A it says, find the slope of the curve r equals 3 sine theta at the point when theta is equal to pi over 3. All right, so as we saw in the last video, okay, for this polar equation, r equals 3 sine theta, okay, we can then consider the corresponding parametric equations that describe the same curve. And here we're just treating the parameter t as the rotation angle theta in polar coordinates. And since x is r cosine theta and r for our polar curve is described by 3 sine theta, we have that x is 3 sine theta times cosine theta. And likewise, y is r sine theta. And so this is 3 sine theta times sine theta, which of course is just 3 sine squared of theta. All right, so then to find the slope of the curve, we want dy dx. All right, and so as we saw in the last video, that's dy d theta over dx d theta. And so differentiating y with respect to theta, got to use the chain rule, we'll get a 6 sine theta cosine theta. And then downstairs, differentiating x with respect to theta, got to differentiate 3 sine theta cosine theta with respect to theta. Okay, here we want to use the product rule. We'll get 3 cos squared theta minus 3 sine squared theta. All right, and then like in the last video, we can clean this up a little bit by using some trig identities. Now 2 sine theta cosine theta, that's sine 2 theta. And so this numerator then, since there's this 6 out in front, this is 3 sine of 2 theta. And then cosine squared of theta minus sine squared of theta, that's cosine of 2 theta. And since we have this 3 here and here, we could factor that out, and this then in the denominator is 3 cosine of 2 theta. Now these 3's divide out, and sine over cosine is tangent, so that simplifies to just tan 2 theta. And so in particular, to find the slope of the curve at the point when theta is pi over 3, I'm just going to plug in pi over 3 in for theta into the tangent of 2 theta, and that gives me the tangent of 2 pi over 3, and that is negative square root of 3. All right, cool. So now for part B, it says find the points on the curve r equals 3 sine theta where the tangent is either horizontal or vertical. All right, so we discussed horizontal and vertical tangents back in section 11.1. So recall that at a horizontal tangent, okay, dy dx is just 0, and at a vertical tangent, dy dx is undefined. All right, so also in light of the last section, 11.2, this equation, r equals 3 sine theta. So what is this describing? Okay, it's describing the circle of radius 3 over 2 centered at the point 0, 3 over 2. So from just this picture here alone, you can see you're going to have a horizontal tangent at the origin, right at the bottom of the circle, and a horizontal tangent here at the top of the circle at 0, 3. Okay, well, how is that seen by looking at our expression for dy dx that we derived in part A? Well, when is tan of 2 theta 0? Well, the tangent is 0, right, when the argument, in other words, the thing you're taking the tangent of, is a multiple of pi. And so the tangent of 2 theta will be 0 when your angle theta is a multiple of pi over 2. Okay, so 0 plus or minus pi over 2 plus or minus pi plus or minus 3 pi over 2 and so on. Okay, so now if the angle is 0 or plus or minus pi or plus or minus 2 pi, okay, you can plug those angles into your expressions for x and y up here. Okay, and you'll find that those angles, okay, describe the location 0, 0. So in other words, we're at the origin when theta is 0, plus or minus pi, plus or minus 2 pi, and so on. And again, we've already noted there that, yeah, we have a horizontal tangent. Cool. And then for the other angles, plus or minus pi over 2, plus or minus 3 pi over 2, and so on. So if you plug any of those angles into these expressions for x and y, okay, you'll find that they all give rise to this location 0, 3, which is the top of the circle. Okay, so that's good. Now for the vertical tangent, when is tan of 2 theta undefined? Well, tangent will be undefined when the thing you're taking the tangent of is pi over 2 or negative pi over 2, 3 pi over 2 or negative 3 pi over 2, so on and so forth, right? So you have to remember where the vertical asymptotes of the graph of tangent are. Okay, so if the tangent's undefined at any odd multiple of pi over 2, okay, then the tangent of 2 theta will be undefined at any odd multiple of pi over 4. Okay, so plus or minus pi over 4, plus or minus 3 pi over 4, and so on. Okay, and if you plug these angles in, okay, you get these 2 points. Okay, we're going to be at 3 over 2 comma 3 over 2, so at this right edge of the circle where we can see we do have a vertical tangent when theta is pi over 4 or negative 3 pi over 4, 5 pi over 4, or negative 7 pi over 4, so on and so forth. And then we're going to be over at this point at negative 3 halves comma 3 halves when theta is negative pi over 4, 3 pi over 4, negative 5 pi over 4, 7 pi over 4, so on and so forth. Okay, cool. Now one other thing I want to note, when theta is pi over 3, okay, where are we located? Well, at pi over 3, we're located up about right here on our curve. And we said that the slope, right, at the point when theta is pi over 3 was negative root 3 over 2. And so this right here would be our tangent. Yeah, and it looks very reasonable to say that the slope here is a negative root 3. All right, great. Well, that's going to do it for this example. Thanks so much.